The first is I'm looking at Australian astronomy here, and in the next slide we'll look at international astronomy. And the Australian astronomy is a relatively new component at QUT, and that's because we've only just recently joined the ASCAP EMU survey. ASCAP EMU standing for Evolutionary Map of the Universe. And ASCAP, it's actually a 36 antenna radio interferometer, which means basically each individual dish is 12 meters in diameter, but the 36 of them together give us a much larger aperture. And they're located in a very remote part of Western Australia, I think about 800 kilometers northeast of Perth. And these radio dishes are designed to observe in the radio frequencies from around about 700 to 1800 megahertz. Overlaps with some of the TV and radio frequencies that we use in terrestrial everyday life. And so we place it in the middle of a remote part of the desert to ensure that we're free from that interference. But the cool thing we do with these radio telescopes, like I mentioned there, is we can look at tracing things like the cosmic history of star formation and galaxies, look at black holes throughout the universe, explore links to radio sources and dark matter in galaxies and large-scale structure in the universe, and create a massive atlas of galactic radio sources. So it's some pretty cool and new exciting stuff that we're going to be doing with the ASCAP telescopes and the EMU survey. It's only just started, and so I've only just started offering positions to postgraduate students. And so no matter what your situation is, whether you're about to start university or perhaps not going to start university for 1, 2, 3, 4, or 5 years, is this thing's expected to last for a long time. And so who knows, by the time you join us, we might be in the thick of things. And so you might be able to join some pretty exciting stuff. The next component, though, is the international astronomy. And so with the international astronomy, we've got a couple of surveys that I actually work with. The first is ZForge and the second is ZFire. And I won't go into too much details about what those surveys are. I'll let you Google that if you are interested. But briefly speaking, they're cosmology or extragalactic surveys, which are tasked with studying galaxies, how they form, how they evolve through cosmic time. And to do that, we actually need to make use of many, many telescopes. And I've pictured 4 of the most common here. We've got the Hubble Space Telescope on the top left, the Magellan Bay top right. Down the bottom right, we've got the Chandra X-ray Telescope. And down the bottom left, we've got the twin Keck telescopes. And so these are all telescopes that I've used and that my team have used to work on these surveys and understanding how galaxies form and evolve through cosmic time. But there are only 4 of probably around about 30 other telescopes that we use. So it takes a wealth of telescopes, a wealth of data to try and understand all of these physical processes that are going on with galaxies. Moving over, let's have a look at the research group. So we're a relatively new and small group at QUT. I was only hired in 2019, late 2019. And so that meant most of my work has been done over the last year, which has been almost a write-off thanks to the pandemic. But thankfully, we've been able to put together, I think, a very solid, even though small team at the moment. And so I show the 4 people of the team. On the left is Georgia, a master's student. On the right is Ollie, a master's student. And down the bottom is David, who's a senior technician. So Georgia works on the role of galaxy environments. So she's tasked with understanding the environment around galaxies and how they may influence a galaxy when it forms and how it evolves through cosmic time. On the right, we've got Ollie, and he's looking at the spectral energy distribution of galaxies. And this plays back to what I mentioned before of all of those telescopes. We get a wealth of data from 30 plus telescopes, and each one may work in a unique wavelength range. I talked about ASCAP working in radio, the Chandra working in the X-ray, the Hubble Space Telescope works in the visible and parts of the infrared. And so when we have all these different telescopes working at all these different wavelength ranges, we pick all of this data together and we can form what's known as a spectral energy distribution of objects, including galaxies. And so that's what Ollie works on and trying to understand. And then down the bottom, we've got David, our senior technician. And as it mentions there, he manages QUT's telescope and dome. So even though we have access to these fantastically large ground-based and space-based telescopes, we do actually also have our own telescope. It's a small 14-inch optical telescope that's on the top of S Block at the Gardens Point campus in the middle of Brisbane City. And it's only used for outreach and education. And the reason for that is probably clear to most of you, but if not, I thought I'd show this short video just to give you a bit of an illustration of why. This is a neat time-lapse video made by David, our technician, showing the dome on the top of the QUT building here in the middle of the city. When you get to nighttime, even though there's quite a bit of cloud coverage, we actually find that cloud dissipates over time. But here we go now, it's nice and clear. There is no stars in the sky, and that's because of all the light pollution thanks to Brisbane City. And so while it's a good education and outreach telescope, it's hopeless for research, but we still use it to inform students on how to use a telescope in hopes they can use one of those other grand telescopes that we were talking about before. Oh, I've jumped out. Let me jump back in. Skip over to the next one. There we go. So some of you may have heard the slogan for QUT as being a university for the real world. So where does astrophysics fit into the real world? It can be a bit of a challenging question to answer, frankly. That's because astrophysics is a fundamental research which has long-term goals for humanity and not really short-term ones. That said, astrophysics and research into space has provided us with a wealth of spin-off technology that I show here, things like personal computers, fast wireless technology, communication satellites, solar panels, mobile phones, medical imaging. These are just a few of those tangible gains that have resulted from research similar to what I do. For example, 100 years ago, Einstein, when he formed his general theory of relativity, we require that today to understand how our satellites operate in space. If we didn't have relativity, then those satellites wouldn't work and you wouldn't be able to use your Google Maps on your phone. Your Uber Eats would get lost on the way to your house and ships would probably get stuck in the Suez Canal. Oh, anyway, but you start to see where I'm coming from is that, these technologies relied on science that's been developed over a long period of time. And so astrophysics research may not provide the solution to some of the most pressing challenges that we have today. It could be long-term solutions. Understanding things like the energy from black holes or stars may help us with our energy problems that we have on Earth today. But what about you? Because from your point of view, if you were to do this astrophysics research, you may not become a professional astronomer or a professional astrophysicist. What's in it for you if that doesn't materialize? Is there something else that you can do? And the answer is yes. You can use those fundamental, well, like I said there, you can answer the fundamental questions about the universe, but you can take those skills that you gain, they're very transferable, and you can apply them to so many other fields of science. And indeed, just this morning, I got a LinkedIn notification that one of my long-term colleagues that works in astronomy and astrophysics at ANU, she's just made the transition into a data scientist to help understand the COVID-19. And so it's amazing seeing these transitions happen from astrophysics into these other areas. And that's because the skills that you gain from being an astronomer or an astrophysicist can translate into so many other areas. Like I show here, there's things like medical physics, agricultural science. And it also plays in part with what you learn in astrophysics. In astrophysics, I need to know the chemistry of the sun and how it operates. I need to understand biology because I need to understand exoplanets, the planets outside of our solar system, and where they sit in a habitable region, potentially hosting life. I need to understand mathematics and computers to understand how to put together simulations of galaxies. And so it's a tough field, astrophysics, but it's a very rewarding one because you'll learn a lot from a lot of other overlapping fields. If you are interested in knowing more about that side of it, I've put a little link to my TEDx talk that I performed a couple of years ago on this very topic. So make sure you check that out if you'd like to. That's all though. Hopefully I was within time. So I'll end it there and I'll pass back over to Kushal and also answer any questions you may have.